didn't understand, like, he was like, different things that I learned in this stuff. Like, right, so he walked to the home and, he's home. He was away. But, the big deal, like, it'll be on a, it messes up the schedule for food. That's when I tell you what, and then, it'll be on a Wednesday afternoon. And then you can shut up. Yeah. That's, but the funny thing is, I realize people are just, like, he's married, he was like, the thing about it is, like, other guys that are about to that, walk them into their own, yeah. I'll just look at what, they're special, yeah, oh, yeah, I can do that. But, there's no, yes, that is true. How do you go? Yes, we need a rebranding effort. Yeah, yeah. It's thick. Stick. Stick. How big is the pin agenda? How big is the pin agenda? Okay. Okay. Can we have 45 minutes, hour? Now? Oh, yeah, now. All right. Cool. All right. First, do we have a note taker? Has anyone? Who is the note taker? Yes. Torlis. Torlis, you seem to have raised your hand. Or a hand was raised near you. What's your name? What's your name? It's a really popular. So keep you engaged, keep you away. You can turn to like different secretaries or people in the IETF, keep in the process. What better way than to hide? So we got two new people. I saw you raise your hand. You can take this. Come on, Joel. Yeah. Really? For old time's sake. All right, so we have a meeting. How about a jabber scribe? Who wants to be the jabber scribe? That's the easy one. Note taking is the hard thing. Jabber scribe. We can't begin without a jabber scribe. You have an armed jabber now? Anyone? Anyone? Usually the note taker is the really tough thing to find, and the jabber scribe's easy, but it's usually Joel who's the jabber scribe. There's not much to being a jabber scribe, I assure you. Okay, Warren is. Thank you very much. All right. Okay, welcome to MBONED. Please note well and all its meanings. Here's the agenda. We're going to start with just go through our working group items. Sandy will be talking about multicast info models. Hitoshi will give an update on mtrace, and Jake is going to talk about an update from the AMT hackathon this weekend. Any questions? Anything we missed? Anything anyone would like to add to this agenda? Okay, moving along. We have two active working group items. One is the mtrace document. We're up to version 17 of that. Is it ready for a working group last call? We'll have Hitoshi will be coming up to talk about that, and that may be probably ready for working group last call. And then there's the peering BCP. After many working group last calls, it finally concluded, and we've begun the submission process. We actually have Tim Chown and Michael Abramson have signed up to be co-shepherds on this document, and they are beginning that process. So that's good news. That's progress we've made since the last meeting. That's a nice. This has been a long-standing draft, and it's nice to move things along with that. In terms of other drafts, there is the info models that Sandy's going to discuss, and also there was a multicast models from Tim and Michael. I don't know, is Tim here today? No? Okay. That was a draft that's since expired, but essentially that draft was taking the stance of making a clear recommendation that SSM is the service model that we support and why, and for interdomain multicast usage, use SSM with a strong recommendation. And we'll see where that is, but that seemed like a good approach. Okay, moving along. So Sandy, if you'd like to come up. Oh, let's get started with the blue sheets. Please sign the blue sheets.
So even though we're joint, we're going to have two blue sheets.
Yeah, please sign into both because these are. There's MBONED. That I don't know what that's going. That won't advance it. Just.
Good morning, I'm Sandy Zhang from ZTE. Today I want to present the update of multicast information model. And in this new version, we add Stig as co-authors because he's useful suggestion. The first page is still the motivation of this multicast information model. There are many existing multi-protocol multicast protocol young models, and there are no relationship among them. So we need a high-level multicast information model to take advantage of these models and control the multicast network to implement multicast service. And this still what is the multicast information model? And this model provides a human readability of the whole multicast network and frame different components to correlate them. And we add a UML class diagram to make it easier to understand the information model. And it's open for future multicast technologies. Let's see the update of this new version. We added the UML diagram in the draft that has been presented in our meeting. And we add example usage of this model, such as debugging, according to Stig's suggestion. And we revise the model in progress. Especially, this model has been verified in ODL build project. And the project will be released in ODL Carbon version. This model is feasible and practicable. Let's see the usage of this model. Network operators can input this model to a controller who is responsible to translate the information and invoke the corresponding protocol models into configurations to configure the network elements through netconf, restconf, and so on. Network operators can input this model to the EMS or MMS to manage the network elements or configure the network elements directly. When the network elements detect failure or some other changes, the network operators can collect this kind of notifications through this model to assist locating the exact failure and reacting immediately. If someone is not familiar with OpenLight, this is a briefly introduction of OpenLight. And we will know ODL employs a modern driven approach to describe the network and the function to be performed on it and the resulting state or status achieved. So we will know young data model is the most important elements in ODL project. You can find the beer project information in ODL through this link. And the whole project is driven by two young models. One is the multicast information model that I am presenting, and the other is the young data model for beer protocol. It's WG document in beer working group. Let's see the diagram of the UML plus diagram. It's so hard to draw a picture in TXT format, so maybe not very good, but we will improve it in next version. So we will see the information comprised by three parts: overlay, transport, and underlay. And the overlay includes the base multicast information and the corresponding overlay protocol or the just the ingress nodes and the egress node information. And the transport is based on the technology that we will use for multicast flow forwarding, such as PIM, MPRS, Cisco mode, or beer. And the underlay includes the protocol that we will use for build the multicast forwarding data plane, such as OSPF, PIM, ECS, BGP, and so on. Let's see the overview of the multicast data model. We make a modification. We move the multicast info to the top of the whole model because of the young rules. But the multicast info is still belongs to overlay. Let's see the information. It's basic multicast flow information, and it's the key of the multicast service. You can see that it includes source address or group address and other information. Let's see the overlay information, but this is not changed in this version. It's similar to the last version. It includes the ingress, egress node information and the overlay technology. Next. Transport. In transport, we made a tenant change that we add new encapsulation types because of the beer MPRS encapsulation structure change. So we add a new potentially encapsulation type for this model. And it's the underlay. Because of this, according to the discussion in last meeting, we know that Babel is a good choice to be used as the underlay protocol for underlay protocol. So we add the Babel here. That's all. Any comments?
Actually, there. All right. What about IGMP proxying, MLD proxying, in addition to PIM? Would that be a useful addition for the overlay? Or sorry, for the transport, I think.
Transport. Okay, we can add it in transport in the next version. I call for working group for adoption.
How many here have actually read the draft? So representation. How many here are paying attention to the Yang work overall? All right. So I encourage you to read this as well. I mean, this is the kind of work that we have to contribute to the Yang model kind of direction the IETF is taking. So the concern here is, we should consider adopting this, but if people aren't reading it, it's kind of hard to get a consensus.
I also want to say +1 to the pictures. Thank you. The UML diagram I found very helpful for just sort of following this presentation. Thanks.
Well, there's some encouragement.
Thank
You don't have to read. It's all in pictures. Make it easier for you.
Read it to your children at night. So although very few people have read it, before we take things to the list, just to get a sense of the room, how many people would support adopting this as a working group item? Okay, looks like about 5, 6, 5, I think. And who would be opposed? Okay. All right. So we'll take it to the list, and we don't, just remind us.
Okay. Thank you very much.
Yeah, just a question in terms of, is there any other example in the IETF? Because, yeah, I've been reading it, you've been asking questions and stuff, but I still haven't made up my mind in terms of how such a more aggregated Yang model has any other, successful examples outside of multicast in the IETF. Kind of coalescing more stuff, let's say the unicast model. I mean, where do we stand with this basic idea of, getting up to higher levels, which I think is very interesting. But if we're the only ones having to, push this through, then I think it's a lot harder than if this idea has already taken traction in other places in the IETF.
You're saying as opposed to a single protocol, most Yang models are a single protocol, and this is a kind of a combination and overlay and underlay?
Yeah.
Does anybody know the answer to that? Any of the Yang experts? Can you?
I haven't really haven't really followed it, but I know in Invest they're also working on a service model for VPNs and not just for multicast.
Yeah, Joel Yegley. So I think service models is actually the area that's most analogous to this, right? So, multiple pieces are required, and they have to be knit up in a bundle, and they have external dependencies on a whole bunch of Yang models that will be necessary to put the thing together. And so, yeah, there's a fair number of those. The success of this entire area, I think, is not yet a guaranteed thing. So I'm not sure we can look at that and point and say that, hey, this works really well, because there's not a lot of evidence of that yet. But once you have a bunch of primitives, like, you have a tendency to start sticking them together into more complex structures, because of course that was what the service providers were going to do with these things to begin with. I don't think there's a justification for saying, well, we're pioneering this and it's uncertain territory. It certainly is, but we're not the only pioneers out here. Joel Yegley, yes.
All right, any other comments, questions for this? Okay. This we'll take it to the list. Thank you.
Thank you very much.
All right, Hitoshi, if you want to come on up.
Okay, so this is, I hope, the last version of the revision of our interest draft. So now is a 70 version. So I do hope this is, our presentation is also my last chance for making the presentation about interest version 2. Okay, next, please. So, but unfortunately, well, not unfortunately, we luckily found one modification, one point that we should modify in the previous draft. Actually, we didn't, we changed the formula converting from the Unix time value to 32-bit entity stamp for using a query arrival time. But actually, the previous version, the formula of the previous version was not wrong. But actually, the metric we have been using is a little bit obsolete version. So we maybe need to change the newer arguments. So that's why we adjusted the formula. So this is the reason of this change. So what is a query arrival time? So the regular NTP timestamp has a 64-bit length, but for making it to compact, we had adapted the 32-bit NTP timestamp specifying the arrival time of the query or request packet. And so we just make it compact from 64-bit. We just grab the middle 32 bits of the full 64-bit form, the low 16 bits of the interior part and the high 16 bit of the fractional part. So this combined and to make it as a 32-bit form. So previously, we used this formula, query arrival time equal blah, blah, blah. But the red part, the TV USEC is a microsecond, is actually given by the struct time value. And this struct time value is given by the get time of day function. But actually, the recent POSIX makes get time of day as obsolete. So this still you can use, but it's better to change the newer version. So we change this old formula to the next new formula. So this is a new formula. So instead of using a microsecond, we use a nanosecond, which is given by the time spec structure. And this time spec structure can be given by the clock get time, which is recommended by the newer POSIX version. So we changed this formula. But even though you are using the previous formula, the result will be given, the same result will be given. So if the vendor or someone already implemented the previous version, it's not a bug. It doesn't give us a wrong value. So you can relax change to this new formula. So this is our modification, this is change. So we do hope that this version is really ready for working with Glasgow. Thank you.
Great, thanks. How many folks have read this? So just a little bit of history. This draft has been around a long time. It was submitted a few years ago and got kicked back during AD review. It was revised significantly, and this is kind of our next shot at it. Since it's been revised, how many folks have read this doc? All right. Cool. It's been kicked around for a while. I think it's probably ready for working group last call. Just to get a sense of the room, who believes this document is ready for a working group last call? Okay, that's all the people who've read it, so that's good. Except
Stigmanas. I just want to say, I think it's been like multiple last calls, and a couple of us read this really carefully for the fifth time or sixth time, whatever, and I think it's a really good shape. I'm kind of surprised.
say that again. You think it's in really good shape?
I think it's in a really good shape, and I'm almost surprised that it needs another last call.
Okay.
That's not my thing.
It's in fairness, it's been a couple of years since the last call. It's due for a last call. All right, cool. And is there anyone who would be opposed to taking this document to working group last call? All right, cool. All right, so we'll take them out. Yeah. Cool. Any other questions, comments? Great.
Okay, thank you.
Let's take this to the list and progress this one. All right, Jake, come on up. So, This weekend, it's perhaps our first ever multicast-related hackathon, or participation in the hackathon. Jake is leading an effort to make multicast cool again, and I think it's our turn to be cool again. It's been a while.
Multicast has always been cool, just nobody knew it. At Akamai, we're looking to deploy a multicast video service. We'll be working on this, going forward. We're using AMT. I think it's a big piece of the step to solve that problem of reaching those who would like to have it, and getting to where we can make use of the scalability gains from multicast. So, jumping over the people who just don't care. All right, so yeah, next slide. This is what we're planning to deploy. We have some pieces of this up, and we'll be looking to make more of them. We're running, so Cisco and Juniper both have implementations in their virtual routers, and we have some some sort of test deployments running, and we're looking for partners to do the ISP side, to do the receiving bit. We have a few carriers interested, and we're talking with them. It hasn't. We could use some more to play them off against each other, or just to participate in kind of realizing these gains. So this weekend, the AMT open source implementation fits our deployment model better. We have many servers, and we'll be running deploying our relays and trying to do some load balancing. Since we kind of have to plan on having many remote gateways, then we still need to solve the scaling problem. It's not going to be the the full sender side multicast ideal, but we can start getting it piecemeal, and the more end users we can reach with the same stream, the better off we can be. So we're using the old implementation was a reasonable starting point. We had to hack it a bunch. We'll be hacking it some more. There's several extensions ongoing.
Which implementation did you start?
Sorry, this is the we found it on the UT Dallas. It's in C. It's I won't say it's nice, but it has some of the pieces that we needed, and was a decent starting point. We hit a couple of interop problems. We had to add a Cisco compatibility mode, so that's in the code, we're continuing to work on that. Any contributions would be welcome. It's open source, and I put the GitHub link on the front slide there. Next slide, please. All right. So this was the lab setup we ran at the hackathon. I had 2 virtual routers running in a box that are connected so that you can PCAP intermediately, and we had some sources on the internet that we were bringing in through the uplink, and then we also had some local sources that were generating multicast traffic, and just sort of it's like my own little crappy multicast enabled ISP essentially, and so we were working on this. The main thing I was working on this weekend was porting the relay code to I ported it to OpenWRT, and that's checked in, and we got it built. I'm not sure we got it debugged. There's some pieces we'll still be working on, but it was a nice step forward. We've got a couple of different sort of video encodings or video transport protocols that we're running. There's we have an internal implementation. We have a Octoshape that we bought at Akamai, and then also BBC and Lucas here was they're working on their service that they've been developing as well. They have a draft, and I think he was going to talk about it just now. Next slide. Just a little bit.
Hi everyone, I'm Lucas Paddy from BBC R&D. This slide's got a lot of information on, and I'm not going to go through it really. Just to give a bit of background, we've been working on adaptive streaming or adaptive bit rate over multicast for a bit of time, using just RTP and sort of traditional ways of conveying HTTP metadata with RTP extensions. But with the developments of QUIC going on, we've been really interested in trying to come up with a better way to convey the HTTP semantics over multicast. And so this is an architecture that can allow that, using alt service as a way to achieve that, although we're bending it. Relating that back to AMT, we've been aware of that for a while, and it's been something on our agenda to look into. We had some issues within our lab environment trying to bootstrap that and get everything working, and so it was parked temporarily when the opportunity came up to test this out on a network that Jake had set up. We took that, and what we found is that our multicast sender, within the lab network, we first tried native multicast, and that worked fine. So the transition to using AMT from the sending side was very simple. I just plugged into a different router, and we could see through packet trace that it was being encapsulated in AMT. So that was a big win. That demonstrated to me it's really feasible. There's some difficulties in the client side, in the receiving. The AMT relay software we used had some issues, and having discussed this outside the hackathon with Jake, there's some challenges to how a client approaches whether to use AMT or native multicast, and I think there's some good discussion for us to have around here or away from here. But yeah, to us it provides a pathway to multicast deployment and standing up a multicast sender that people say who might want to implement the HTTP over multicast quick draft that I've got, or try and interrupt with something. They have a means to do that across the world. That's all I've got to say.
Yeah, next slide, please. So this is just sort of the pieces we got working. There's several we have left to do. There's IPv6 is not present in that implementation. That's one of our high priorities, and also there's some as Lucas just mentioned, there's some usability issues with the gateway. I think that a better model is probably embedding it in receiving applications and working from there. So we'll be looking to get that relatively easy to fold in, and probably adding it to a few things that can receive such traffic, maybe like VLC and maybe IPER, some of these pieces that are capable of doing such things. Next slide, please. So I just wanted to give some acknowledgments to the folks who worked together on this and who made it possible. The prior work we were building on was, in the comments in that code said it came from, it was a contribution of the MBONED working group, and Bill also, has done some work. His lab has done some work with embedding it in VLC, I believe, which I didn't get a chance to look at, but it's on my list also. Somebody who I hadn't met before, I hope I get his name right, it's Kadaran, I think, contacted us because of the hackathon announcement and worked together on it. He was working to install it also on his home router. And that's it. Questions?
Donald Sharp. This might be more of my ignorance. What's the difference between AMT and like the most kernels diff tunnels?
Sorry,
So Linux kernel provides the ability to auto tunnel via the kernel multicast routes.
well, so AMT is packet encapsulated across the internet is the main thing. So it's unicast UDP packets that contain the multicast headers, and then you know, as you send them, then you unpack them and
I
forward them.
guess what I'm saying is you can tell the Linux kernel create a tunnel between two spots, and it'll do that for you.
Oh, sure. So one of the main So there are other ways to do tunneling, right? There's GRE, and so there's a few nice things about AMT by comparison, and one of them is that you don't need to set up both sides, right? You can sort of set up one side independently, and just like if you had a multicast backbone, you could, you know, somebody remote could just sort of join and start receiving things. Somebody remote can independently set up something. You don't need to coordinate between them and start receiving things. And then it also has some features that enable scaling, such as the discovery. So there can be discovery servers that can decide sort of which relay is going to be serving this stuff, and then they would talk to that relay, and then there's some signaling to say, well, stop using this relay, go rediscover another one. There's signaling from the gateway side to sort of tell the relay, I'm done with this tunnel, tear it down. So it's easier to negotiate with remote partners.
It sounds like a lot of the work that was done at the hackathon was focused on the relay implementations. Can you talk about what is the state, and maybe, you know, Bill, you can also talk about the work you guys have done. What is the state of AMT gateway implementations today? I know there was work done by UT, work done by Concordia, work done by Octoshape. They've announced all three of those have at some point in time been announced in the last few years here. What have you found?
Right. So as I said, I think the better model for at least for what we're doing is to embed the gateway into a receiving application, and we've done that with both of our Octoshape has this built in, right? And they didn't require them. And then also the other video implementation we had been working on previously kind of did the same thing. So I mean the protocol is not that complicated, so you can make that happen. I think there is some value in doing it at the system level, but just it's not practical to rely on that at this point is kind of where I am. And so there's and you were asking about the current state of the Git?
Yeah. So I mean, the simple question is, if someone wanted to deploy an AMT relay and see it working and get their MTV, what would they use? What's out there today?
I would probably, if I were starting over today, start with RTP and try that.
Start with what?
With RTP and try that, and so the video stream that you're going to send would, there are some working implementations, the GStreamer kind of thing, and so I haven't played with that as much yet as I wish I had. We've done the work that we've done has been more focused on segmented delivery and sort of reliable transport of the segments, and then through a proxy running on a client side, so that you can make it sort of seamlessly transition between unicast and multicast, which also we think we need in addition to the AMT. And we haven't figured out how to do that with RTP yet, or whether that's practical, but it's, I think, also something that we would consider and look at going forward. Certainly, you can run Juniper and Cisco both have relay implementations in their virtual routers. I think you can I'm actually not sure if the version that you get, like on Amazon EC2, has it in there, but I think so. Or if it doesn't, then it would. I would expect it to be there soon. I think the latest releases as of like last November or so did have it in there that you just download the virtual router. So you can spin up a relay and try it. And then on the gateway side, Cisco has a gateway implementation. That's the one we were using in the lab, and that works great. You can also work on the open source project and get the gateway functioning. It's going to need a little work. And that's certainly on the list as well. The gateway as it stands sort of insists on opening a tunnel interface and then forwarding the packets out with raw IP, and then the receiving, when I run it with like iPerf, and the receiving iPerf will propagate the join through properly, but then doesn't receive the packets yet. So kind of this current state is not really ready for prime time, but it's close enough that you can hack it if you're willing to spend a few days at it. And I just I've been busy.
Greg, do you remember the URL for the open source implementation we did back in Cisco? I wanted to forward that to.
Yeah, there's a GitHub stack. I'll email it to you.
Thanks.
I'm just looking. Amazon EC2 says iOS XE 3.16 3S.
Okay, so that does have it. Yeah.
Just wanted to thank you for putting my name up on the slide. I'm Bill Atwood. The only other comment I wanted to make, I haven't touched this stuff for a couple of years, but in the interim, we've done some work on how to secure AMT, so that if you're concerned that the customer really is the customer, we've got some work that I can point you to on that. But because AMT, like all IP, is unsecured packets with no flow or anything.
Right. Yeah. Our thoughts on that were more like, do it with the sort of video transport encryption key kind of ideas, right? So all the segmented protocols have, you can encrypt the segments with this key, and then you can have that key just an independent HTTPS login based thing, and you can get the key that way, and you can't decrypt the segment without it. This has some problems, and I think there's still some work to do on that. It actually, though, it reminds me of a great point. We're concerned about the AMT data packets while we're trying to transport sort of across the internet. I think the original intent for AMT was sort of a little lower down, near the home or something. But since we're using it to sort of go between ISPs, we have this problem where if there's a potential off-path attack for packet injection, because there's no nonce in the AMT data packet. So we may at some point want to do an extension or something. Part of the problem is that if you can figure out what gateway is receiving actively right now with what remote port, then you can send a packet and that'll just sort of be accepted. So if you don't have like a completely BCP38 compliant internet, which we don't, then you can have an off-path attack that will inject packets, and this is an issue.
No, you could cut the receiver off by just sending back a packet saying I'm not interested anymore.
Right. So that's another layer of it for, and certainly, yeah, I'd be interested in seeing it. Thank you.
Yeah, I can give you some pointers.
Bits and Bytes. We'll have a table at Bits and Bytes, and we'll be showing I'm going to put back up my little setup that I had in lab, and I'll be running some video over it and drinking beer. Please come by and talk.
How many folks did you have working at the hackathon?
Just the three of us. Our one remote participant.
Okay, cool.
We would welcome more participation.
No, it's a great start and great idea, and very, very exciting. So, thank you. All right, a few last things. Has everybody signed the MBONED blue sheets? And just a reminder, please, there will be PIM blue sheets. Please sign those as well. A few other announcements before we go. We are interested in, for MBONED, we are considering the idea of adding a secretary. So if you've ever been interested in a leadership position in IETF and learning in the process and getting more involved, it's a great opportunity. If you're interested, come see Greg and me, and we'd be happy to share what a secretary is and does. And like I said, it's a great way to participate in the process. The last thing, there was a video beer boff last night, minus the beer, and a bar boff, minus the bar. And maybe Greg can kind of talk about last night, because multicast, a lot of the topics that we're talking about today, did come up. So Greg made it through the whole thing, and
right. Yeah, thank you. That was an effort. So we had some of the folks from the room I noticed were there as well. I actually heard about it the last minute, so I didn't have a chance to really read the problems, what they're addressing. I found out after the fact they didn't even have a problem statement draft to even address. I think the description of the BOF drew lots of attention, and the majority of the people in the room were there for the discussion that was from the description. What we got in presentation really didn't seem to address that, but that's kind of a side event. I'm not going to discuss it. What we saw, I think what Jake, you pointed out, this need for, you talked about scalable multicast video or potential scalable internet video, maybe not directly focused on multicast, but when the one issue that came up was they talked about, oversubscription, congestion, and then they gave a presentation that was just putting more bits in the header, which I don't see how that addressed the congestion necessarily. I mean, there was maybe an architecture shift could have improved some of the bits, but the hands that raised right away, you said multicast? You said multicast? I think there was at least two other people that said the same thing. But Dave Moran had a kind of a broader perspective on all of it. It's like, rather than just going right after the network, let's talk about all those things we have. IETF is not addressing codecs for whatever reason. We got transport solutions there. We can potentially improve the network. We can coordinate between the two. So I think there was a broader community to do something. What was presented would be one slice in there. But what we asked was, let's get a problem statement together and prioritize them, and then see if we got a better community support.
There was a hum for at this bar-off that showed strong support for a need to address the problem of scalable video on the internet. Their presentation, as I understood it, was an attempt to address the scalable video problem, and essentially by enabling deep caching in some. They see it as enabling deep caching in some way, and that is one thing that might help with scalable video. But yeah, what they're really asking for is sort of a venue to discuss scalable video, which I also would like very much. Yes.
Yeah, so I think one of the core questions to answer from the folks who have an interest in this, in my opinion, is the amount of delay that you're willing to accept, because that has the biggest impact on the solution that you can do. The more delay you can accept, the more you can, do these things of having these big, ABR-like blocks. The shorter the delay is you're willing to accept, the more you're getting into an RTP type solution. So I think that's always a thing where.
By delay, do you mean join latency, or do you mean the video?
Total propagation, eye-to-eye propagation. Right? So if it's basically you're just trying to do a large scale out replay of something that was recorded, you can use a lot of other tricks than if you're trying to do a live video of a sports broadcast that, you don't even want to have your 20 seconds delay that normally, all your ABR buffering does, right? So when it comes to the higher layers, both of them can be nicely done with multicast, but the next higher layers, what are the codecs? Can you do retransmission? Can you do big blocks of, ABR stuff or not? I think that's really the core question to answer. How much delay are we willing to accept?
And was there a consensus to how much of to use multicast, or were they just talking mostly about problem statement? Was,
Right. There was no
as a
sense in the
solution.
room to take a consensus of solution. That wasn't the point, right? But there was a consensus of interest to address the problem in some way. And I think an ask to the original, I guess, presenters there to let's get a problem statement so we know what we're going after. But a sense of the room, like who thinks there's interesting stuff to go after, and there was a broad sense of support in the room.
Right.
Young man with a
Right,
blue shirt.
Huawei. So I'm still trying to understand really what the purpose of that. This is the first time I'm hearing about it. Did they get into things like virtual reality and high bandwidth requirements in that world? And
No,
what kind of
there
video
was just like a hand waving about, it's bad, spinning wheels, and then they gave a little book report of some code they wrote.
Oh, they did. Okay. So basically,
Were those 4 drafts not accepted anywhere else? Are there active drafts in other groups? Oh, without a home. Okay. I thought they were in the SR work. All right. Let's do it.
Where can we figure out? Because, sorry, I was totally,
Pardon me?
I was totally not getting this thing, so I was just wondering, where was this announced?
Right. So it's not even on the BOF list.
It's an informal activity.
Okay.
That's fine, I'm just trying, if there's something like 4 drafts,
Sure, yeah,
I'd like
fair
to
enough.
find my path through to them.
So as an informal activity, there's not like an IETF process that they're going through.
Hopefully there's no process at all.
Good. That was clear.
okay. So the reason I ask is I've been contemplating over the last couple of months, having delved into virtual reality specifically over the last 6 months, and the
Virtual reality or virtual routing?
virtual reality,
Reality.
non-networking.
You're not
putting
here.
on a head mask.
There is no spoon.
Yeah. So, and it's really cool, but there's intense bandwidth requirements, and I was hoping that a place like MBONED would address some of the things that at least
that would be a
document.
particular use case that could supplement the problem statement in some way.
I think that would be useful here.
Yeah. You think that's air you're breathing now?
Yeah, I mean, just in follow-up, there was a presentation from another Huawei colleague in ICCRG yesterday talking about the problem statement, and then also kind of looking at, the amount that the current congestion control schemes, for example, obviously starting all unicast, but with TCP and others are, insufficient. And there was a lot of feedback that was also pointing, into more this low latency real-time RTP and the other schemes that we partially did experiment with in the past.
I think Quick was brought up too, right? Trying to look at ways to exploit Quick.
This is not the protocol you're looking for. No, sorry.
Well, yeah. Well, that's what Oran was pointing out, right? Just you can't go after everything with the network hammer. There's transport issues, there's network issues, there's application issues, there's codec issues. Things can be resolved in various ways.
Yeah, I mean, AMT sort of points out that like we're still worrying about ways to encapsulate things in funny ways because that makes them opaque to the network, which actually is super convenient because then the network doesn't have to care about them, which was a big impediment to deployment to begin with. So like Quick exists because a similar problem exists with unicast, and so like I think like that solution space is still being explored, and it would surprise me very much if it didn't overflow into the multicast domain, like certainly when it comes to video delivery. So yeah.
So if nothing more, let's keep our eyes open because I think it may become a formal BOF request, possibly in Prague, so we can.
No problem.
You gone? Is this it?
Yeah.
When's our big party? Is that this week?
I'm partying now, but no.
Sanctuary.
So yes, I've been your AD for 4 years. You're now in the competent hands of Warren Kumari as of Wednesday. Oddly enough, I was here before being an AD, and I will probably, you'll probably get to suffer with me afterwards. So there you go.
We thank you for your service.
Yeah.
The 4 years went by quickly. And Warren, would you like to introduce yourself to the? We'll be seeing more of you.
Not as tall as Joel.
Yeah, I have that same problem.
So hi all, I'm Warren Kamari. I haven't been participating in this at all. So this is all new to me, and please, give me some time to learn things. And when I'm getting stuff wrong, just bat me upside of the head with a twist stick. And thanks to Joel for running this. I'm sure he'll have comments if I get stuff wrong.
Yeah. Welcome aboard, and we hope you have as much fun as we do. Great. Anything else anybody has to add? Questions, statements? Okay. And with that, oh, I'm sorry.
Donald Sharp. So recently we were doing a lot of multicast testing on the Linux kernel, and we found a pretty big problem with multicast forward, and it created a hash table based off the higher order bits of the group. So if you have a multicast table, if you use the same multicast group, it would store the hash and the same thing. So once you started getting more than 2 or 3 or 4 routes, multicast routes, your performance for forwarding on Linux sucked. So if anyone's using Linux, please update. You look like you've seen this. Yeah. Yeah, it's going to be in the 4.11 kernel. Go get it.
Yeah. Good to know. Thank you. And feel free to mention that on the mailing list too. I think a lot of folks who aren't here would be interested to know that. Any other comments, statements, questions? Okay, with that, MBONED is done. PIM will begin, and we'll see you in Prague.
Five-minute bio break, please.
It's only 1 hour.
Yeah. This is a virtual single working group.
These are the blue sheets, these are the PIM blue sheets. They're different than the blue sheets.
We should ask, I guess, if they are willing to take notes for us. Is it too much noise? Just perhaps it's too much noise to do it or not? Keep doing it. It's like one session. Yeah. Joe, would you be willing to take minutes for PIM as well? Awesome. Thanks. Did we have a Jabber scribe for MBONED, and are you willing to do PIM as well? Okay, so that's easy then. Oh, thanks.
Yeah.
Okay, welcome to PIM. We know this is really why you came, so thank you for being here. And we probably have like an hour of agenda today. So here's the agenda. We just put 10 minutes by everybody's names, but we can go less or more as needed. We do have a few Yang related drafts, but don't fear, there are other non-Yang related drafts that we're going to discuss as well, for those that may not be Yang interested. Does this agenda look accurate? Okay. All right, let's just take just a couple minutes talking about some of the active drafts and what has been recently published. So the drafts in bold we'll be discussing today, so we'll get an update on them. The two that I don't think we're getting an update on are the DR improvement draft and the multiple upstreams drafts. Are the authors here? Is there any update that anybody wants to give on those?
Hi, Carlos Bernardo. I'm author of the multiple upstreams. So I need to synchronize with my co-authors during the meeting, but we hope to be able to send an update before PRAC, like in a couple of weeks. Sorry for not making it happen for this meeting.
Okay, thank you. Do you understand all that, Joel? Okay, very good. You know anything about DR improvement, what the latest is?
Yeah, so we're wondering what the status of the DR improvement draft is. Are the authors planning to make an update of that draft soon, or? Okay, well, we'll check with the authors and see how it's going and what the plan is.
Okay, all right, fair enough. And we have not published, but we have requested publication for the PIM Yang draft, and I think the Yang doctors are reviewing it right now. Is that your understanding?
So it has already been reviewed. It's mostly now left to the ISG and check that it's kind of, what should I say, compatible with other IETF models, and hopefully it will be done soon. And I want to say in general, we've been told that we need to kind of get the Yang models done quickly if we can. There's lots of people that want Yang models, and there's other organizations than IETF that are coming out with models. So if you want the IETF models to be relevant, we need to get them published soon. So we're trying to see if we can get this done quickly.
All right, so let's go ahead and if there's no comments there, we're going to go ahead and get with the rest of the agenda then, starting with STIG. I got it here.
All right, so I've been presenting this draft quite a few times over the last years, and so hopefully most of you know about it. It says BSR in the title just because when they did the initial version, they were thinking about doing something related to BSR. Anyway, next slide, please. So, as you might remember, this is some way of announcing active sources within a PIM domain. So we're using some sort of little bit BSR-like mechanism for flooding this hop by hop within a domain so that all the routers can know the active sources. And basically, without having any RPs and registers, we can have source discovery and forwarding on shortest path trees. Nothing much have happened to the draft lately. I got some review comments. I've been improving the text a little bit, but the actual technical content is not really changed. So I feel like I'm pretty much done with this draft. There isn't much more to do, at least that I can think of. There's currently two different implementations of this, and there's at least like 3 or 4 different organizations that are considering deploying it, or at least showing interest in deploying it. Next slide. So, yeah, and one of the implementations have already been tested by one of the people, or some of the people that want to deploy this. And at least for me as an author, I feel like it might be ready for working group last call, but I'll leave that to the working group and share it to decide.
What's the target status?
What's your name?
Oh, I don't know. I have to ask the note taker. Thomas. So sorry. So what's the intended status?
Great if someone can check what it says in the draft, but I would say experimental seems right for this. I should remember that. But hopefully I made it experimental.
Okay, so who has read this draft? So we have 5 hands. Who believes that it is ready for working group last call? So we have, okay, 5 hands. Okay, so, all right. We obviously would, as usual, take it to the list, but it seems to me like it's probably ready for working group last call.
Right. Thanks.
Gopeng, are you here? Yep, very good. There we go. Is it? No.
Yes.
Is the right one?
Yeah.
Okay.
Good morning. I'm Gopeng from Huawei. I would have an introduction for IGMP MLD model. So we have been working with a group of vendors for this. So the current progress is reviewed by young doctors, and we have updates according to his opinions, and we have passed the validations. Next, please. Okay, I would introduce 2 things. First is the structure of the young model, because young doctors ask some questions about the structures. Then I give a brief introduction for the updates. Actually, we have separate models for IGMP and MLD because they belong to different address families. So this makes it easier to choose different address families. The second one is there is 3 modes for the attributes: global level, interface global level, and interface level. So global level means status for the entire instance, entire system. Later I'll give you an example. And the interface level is attributes applied to specific interface. So interface global level is the attributes, actually it's per interface status, but as long as the specific interface doesn't define that status. So next, please. Okay, this is an example. For example, for global level, if you choose maximum entries, it means maximum entries for the entire instance. And for interface global level and interface level, we give an example. So, for example, if we define the query interval in a specific interface, E1, so that means interface mode. But if it's not defined in the specific interface, so we should inherit the definition from the interface global level. So actually it's per interface definition status for that. Next, please. And this is updates. first we change the augment level to control plane protocols according to the our purpose for that. And then we change the how to extend the parameters for different values. So in the previous draft, we defined the maximum range among the vendors for that. But according to the suggestions of young doctors, we use the choice for that. In the choice, we define the basic range for that, the minimum range for that. And later, the vendor can extend it according to his implementations. So this shows an example for that. Next, please. Also, we have some updates because we didn't define some default values for the models, so we added those values. Next, please. We apply to that call and welcome your comments on that. That's all.
Any questions for Gopeng?
Just general policy, just general question in terms of how in other places the quality of Yang model has been measured, right? So because if I'm looking at it, I'd be very interested whether it's in MBONED or some other place to see kind of this. Okay, so we've compared 3-4 implementations and vendors, and here are the features that didn't match, because I mean this is sometimes this is a consortium thingy, right? So kind of every vendor fought for some particular subsets of what they have. So I'm just trying to figure out how that in other areas has been analyzed to figure out how good it is, right? I mean, because in the end we want this to be standards track, and I think we'll get some initial state of that. So where does this go, right? So we start out what proposed standard, and then kind of what's the next step in terms of creating a document that says, oh, this is so wonderful, every operator could do all the things he was doing with CLI and before, or no, sorry, it was exactly not the case, because there are all these wonderful objects, and whenever you try to use them, they didn't match what my vendor had. So I mean, is there any prior experience how this part of the process works, or are we just well, I'm going to that.
Okay, I can comment on that. So we have a design team with people from, I think, about 5 different vendors that have been working on this draft. So they have been going through different implementations, trying to find what are the commonalities and so on. And you don't want to put too much mandatory stuff in here, because then it's impossible to support a model for some vendors. But trying to find what is common, and then each vendor can augment the model with things that are specific to them. But yeah, there's, I think, about five major vendors that have been working on this. And there's people that are pretty experienced with Yang that also are part of that work. And the Yang doctor had fairly minimal comments. So at least I'm not a Yang expert myself, but I got the feeling that the document is in good shape personally.
So I see authors from 4 companies. So is the kind of list of vendors who contributed the knowledge about their implementation, is that listed in the draft? Just to
maybe you can comment on that.
Other companies contribute to this.
I was just seeing 4
yeah,
authors
so
from 4 companies. So I was just.
So I know I would have to go and check, but I know on the mailing list there's additional people that have been involved discussing that are not among the authors here. I don't know if the whole team has been discussing this, or if it's just the authors.
No, this is done by the design team. The whole team design team reviewed.
So yeah, so there are not just the authors. There are some other people that also have been reviewing this, or
because we have sent to the mailing list, but not feedback from them. I don't know.
Okay. Yeah.
But because we have in the past we had a meeting, design team meetings. All of them are in the meetings.
Yeah. No, I remember there were some. We have a wiki for this, and there are some matrices showing matrices showing what is implemented by different vendors. Did you have
Sorry, I haven't read the draft in all this for detail. Is there pointed to that wiki? Do we think that wiki will survive? I mean, because this collateral information, I think, for every operator that picks up the draft, I think is very important to know, right? Kind of how many, vendors implementation, people brought feedback into the wiki, that comparison. So I think all these things sound like great to give confidence in adopting that Yang model. And I would hope that in the next round when, operators are starting to use it, then maybe the next round, what I was saying, would be collecting feedback from those operators, right?
Actually, I don't know, if you have time, I could just quickly show what we have here. But,
you want to do it? Or not? Yeah, we have time.
Okay. Let's see.
Should I wait?
Go ahead.
Okay. Jake Holland. I just now skimmed through the draft looking for pictures. Would it be possible to add add appropriate diagrams, maybe to? I think it was a great idea. It was in the MBOND session, and just adding like block diagrams to indicate which parts of the config address which elements of the network would make it a lot easier to follow and to consider, I think.
I'm not getting with you. So.
Sorry, I'm suggesting in addition to the current document, which would be the diagrams that would provide a mapping between different network elements and the appropriate configurations, so that it's more clear what these elements are tuning as the configuration is used.
Yeah, a summary diagram the configuration from network elements.
Yeah, one thing I heard is a common mistake with models, in IETF and maybe other places, is that people don't have descriptions that are detailed enough for people to understand exactly what are these different leaves, actually configuring or reading or whatever. But yeah, I just wanted to show you this. So if you go to like the PIM status page, you can click on the wiki here. And then you get to the PIM wiki, which doesn't really have much, but there's a link to the Yang multicast team wiki here. So anyone is welcome to join this team. It's an open mailing list, and we will be happy to have more people taking part. But these are people that have been involved in this from, you see, actually there's more than 5 vendors, there's a few operators too. I would say not everyone has been contributing equally much though. So some people are much more active than others. But if you look down here, for like the PIM model, went through like different configuration items. You see here for like 7 different vendors, there are 8 different vendors. And if you scroll further down here, there's also similar things for IGMP down here. So this is showing like what kind of IGMP config. Okay, I guess there's not detailed from all the vendors here, but yeah. So at least this shows sort of what different vendors are supporting, and based on this, it was decided what to put in the model itself. So Torles, you think it could be useful to have something like this in an appendix or something in the draft, or have a link to this
I mean,
page,
as long as the IETF doesn't kill this stuff in case PIM should go away or so, just a pointer to this would be great. I think this gives me a lot more confidence than I could get just reading through a draft and only knowing one vendor's implementation, for example, right? So this is cool and definitely needs to be referenced in the document.
Hi, Alvaro Rutana, Cisco. I just want to point out that there's an RC called 7942 that talks exactly about this. It recommends that you put a section in there that talks about implementation state and where to find more information and all that stuff. So that when people are reading the document, like Torles, they can actually find information or know who has implemented or etc. In many cases, because that is of course going to be dated information when the RFC gets published, because it's never updated, it may be taken out. for publication, if that's what you want, or it may be left there. I can't guarantee, and I don't know if anyone can, that that wiki is going to be there forever. In any case, it would have to be maintained for the information to be relevant right in the future. But yeah, take a look at that RFC. It's 7942 to include the information in there.
Thank you. Thanks. So we were thinking about maybe doing a working group last call on this soon because we want to get these models out. But it sounds like we want another revision with some of these things put in there before we consider last call.
So just a quick point to that, right? So if this is meant to be a living document or so, I mean, it would certainly be good for the wiki to just pull the version at the point in time when the document isn't changed anymore, right? Because I mean, the reference is not whatever is currently active on the wiki if people continue to contribute it, but what I think is important as a reference for the RFC is exactly what was there by the point in time when we closed the document, right? So maybe create a copy in a subsection and say this is the last version of this wiki that was taken into account for the RFC.
Right.
Okay. So yeah, go ahead.
Okay. Just curious, how many people have read this draft? Torles has read it. 2 people. Okay. Well, yeah. Okay. Yeah, I read it too. So at least 4 people read it. Yeah, so I would say let's get another version with some updates that you planned and think about getting a copy of these tables from the wiki. And then we'll maybe ask on the mailing list if people think it's ready for last call, and we'll try to ask you guys to read it. And actually, it's great if you guys will have a look. And if you're a vendor, you should check that is this something you're able to support, and also if you're an operator, does it actually give you the data that you need to operate your routers?
Thank you.
So just as a side note, one other thing that gives me comfort is that with these Yang drafts is that people like Shufang and others are involved in Yang drafts in many other working groups. So there is some consistency going on there. Well, at least we're relying on that, and that we're not just doing things on our own. So I think we're clear on that draft, that we'll make an update with some diagrams and then do a working group last call. Yeah, that sound good?
Yeah, I can also mention that there are like a lot of other routing models in the IETF, and the Yang doctors and RASG are helping to make sure, and also Shufeng are making sure that the models are aligned and can actually fit together. And there's also some Yang drafts that define like some IETF data types, kind of that these different Yang drafts are using and so on. So there is some attempt at making sure that these things are aligned.
Okay, so I have Sandy on next, but I don't think I have your slides, Sandy.
Oh, they are there.
Oh, they are? Do you have them? I don't know if
They're posted on the webpage.
You hear Sandy, right? Sandy? Yeah. Sandy.
Don't you have the meeting materials on the agenda?
Yeah, I think I do. Hold on.
There they are. I missed it.
Okay. Oh, yeah, I do have them. Never mind, it's PDF. Got it. Yep. How do you do it? Yeah, okay.
Okay, I'm here again. I want to make a report about PIM MSDP update. Next. The working group 00 version is a status update of draft Jump PIM MSDP version 2 that is presented in our meeting. And this YANG model is according to RC 3618. And the scope covers MSDP protocol and the commonly used configuration. This model defines a YANG data model for MSDP configuration and operation. It includes high-level structure, configuration attributes, operational state attributes, statistics attributes, and RPC. And this YANG model is based on the consensus in the YANG multicast design team. So you can find the discussion process through the link of mailing list. And you can find the website, wiki website that's shown by Stig. Our discussion content is on that website. And this draft is versioned on GitHub. You can find all the details and the history from this link. Next, we must adjust the reference of keychain because of some changes in the models we depend on. And we must revise some spelling mistakes. And the most important, we need young doctors review.
Okay. Very good. Go ahead.
So this was also been worked on in the design team, right? See on the wiki there are some matrices for MSDP. Yeah. Let's see. Yeah, well, this one thing is we should consider, of course, the same that Torles said for the previous draft, to somehow refer to the wiki and maybe have this matrices in the draft. But I don't know. I need to have another look at it myself too. But at least this is, yeah, basically, what should I say, agreement or consensus in the design team for the draft. Yeah. Yeah. I don't know. I'm thinking, you know, I'm guessing not too many people have read this either. So just like the IGMP MLD draft, it'd be great if more people could read this. And yeah, we'll ask a young doctor to look at the draft as well. And I'm not sure if we'll manage to do it before the next meeting, but at some point we will ask you guys either on a mailing list or in a meeting whether you think it's ready for last call.
Hi, Jay Collin. I think I'm going to do this to every Yang draft I see from now on. It's I would find it helpful if a network diagram indicated which parts of the config were applicable for the various options or sections.
Okay. I think you can discuss in the design team.
And again, though, yeah, please read this. And if you're a vendor and operator, you should be interested in what this model contains.
Thank you very much.
Okay, so last few drafts have been working group drafts. Now the next two drafts will be individual drafts. Yeah.
Hi, this is Ashutosh from Cisco. We have had RFC 5549 for a while, where BGP through one session of BGP, multiple address family prefixes can be exchanged. A lot of customers are using it because of the control plane efficiency. And while doing unicast with that option is fairly straightforward, in case of multicast, there are certain challenges. And when we have, like an example topology here, if you have your RPF neighbor in IPv6 address family, you need to find your IPv4 PIM neighbor accordingly to send upstream join. Whereas there is no standard way to do it. There are multiple cases where you could have multiple PIM neighbors on the same interface, and etc. So that's the overall problem statement we are trying to solve. And if there is just one neighbor on that interface, then it's fairly simple. You can go ahead and use that as your RPF neighbor in IPv4 address family. But if it is not, then we have RFC 6395, which introduces an interface identifier, which is a combination of a router identifier plus interface identifier, which if IPv6 PIM, PIMv6 and PIMv4 are both running between the boxes or routers, they can exchange the same interface identifier, and that would be a key to find IPv6 or a key to translate IPv6 RPF neighbor to IPv4. But if that is not the case, and I mean is if the network has only PIMv4, then in that case we cannot use that approach. And there is another, so depending upon the case, there are two scenarios where you could use a secondary address list in PIM hello option, and each PIMv4 neighbor can advertise IPv6 secondary IPv6 addresses in PIM secondary address list. And in that way, when you have your IPv6 upstream next hop, you could look up that in your PIM neighbor cache and find out your PIMv4 neighbor. In some cases where your IPv6 next hop is not directly connected to you, it's like in that case you might have to resolve the MAC address of that IPv6 next hop, and to match it to an IPv4 neighbor, you need to PIM needs to advertise that MAC address into PIM hello message. This is an additional proposed PIM hello option. A secondary address list option is already implemented in system implementation, and we are shipping it. We all know at least there is one customer who is using it in production. Thank you.
Donald Sharp. So why do we need three solutions?
It is about the efficiency. I mean, if you have PIMv4 and PIM6 running, you can do everything within PIM. Basically, you can find identifier within PIM. If you don't have, there are customers who are using only v4 multicast. They don't want to enable v6 multicast, which has additional overhead. In that case, you can go ahead with IPv6 secondary neighbor list option. There are certain cases when you have recursive next hop where you won't be able to find your IPv6 next hop directly connected to the box. In that case, even if you, so your neighbor would not be including that particular IPv6 address in its hello. In that case, that option wouldn't work as well. You will have to basically find it through MAC address, which is kind of a last option because it involves neighbor discovery and MAC address resolution of the particular IPv6 address. We went with the best possible option we thought, which is secondary list option.
So why don't we just remove the other two options and use that one?
Sure. We were looking for feedback from, and certainly doing with interface identifier option looks better if PIMv4 and v6 are both configured.
Well, I guess it's pretty obvious not everyone configures v4 and v6 PIM. So
it was a feedback from customer that they don't want to, unless until they are really doing PIMv6 multicast. they don't want to configure it just for the sake of making this solution work.
Yeah, I want to comment on this too. So I'm one of the authors, by the way. So I'm not saying this as a chair, but yeah, basically, if you only have deployed v4 multicast, you don't want to enable v6 PIM just to be able to send the hellos and use the interface ID option. So I want to add that the secondary address list option, in a way, this is exactly what that option was made for, except it was, when it was created, the option was defined, it was only for v6 kind of, but it doesn't explicitly say that it's only for v6. And the whole idea is that when the RPF neighbor is not the primary address, then you check the address list to find your RPF neighbor. So it's exactly like how it was defined before. The only difference, which is slightly weird, is that you have these 6 addresses listed for a v4 in the v4 PIM packet.
I agree with all of the solutions would work. I guess my point was, I'd rather not as an implementer spend a lot of time implementing 3 different solutions. That would just make me...
Yeah, no, I agree. We don't really want that, I feel. So yeah, it's more like getting guidance or input from you guys for which options you think are the most reasonable.
I like the one you implemented.
Do I understand the use case right? The use case is that unicast V4 is being carried over V6 infrastructure, and people don't want to enable PIM V6 simply because they have a V6 infrastructure? Yeah, that's right. Right. I mean, do they also like to use V4 OSPF? Right. I mean, nobody else thinks this is strange? Nobody else thinks this is strange? Well, that's not strange, right? But the connectivity is V6, right? So you might expect to have to use V6 aware protocol. Does anybody use the variant that works on the MAC address? That really sounds kind of hacky. The variant that uses the MAC address to identify the PIM? Yeah.
Yeah. Yeah, I mean,
that seems like a direction you might want to try to avoid.
That's true, and that's why it's not intended, but we are looking for feedback as well. In case where you don't have IPv6 as directly connected neighbor, what other options can we have?
You have IPv6, right? That's the use case, right? That's the underlying infrastructure is IPv6.
Yeah, but the idea is having one control plane, and that scales better than having 2 sessions for both IPv4 and IPv6.
And you don't wouldn't use PIM-v6, right? Because
it's the configuration and control plane overhead. Sometimes licensing issues as well.
We're good. I don't think there's a question here. Just I guess the request is to just review this draft by the working group. Is that your request? Okay. So please do that. Thanks for your feedback. That was Eric Rosen speaking last, by the way. Okay, thank you. I think Jeffrey's last.
think that works. Yeah, sorry.
Okay, so this is about the signaling BGP trees using signaling multicast trees using BGP. The co-authors from Juniper, Arcus, Cisco, and Thomson Reuters. So why we are talking about this? So there are many operators, especially data center operators. They do not want to burden their infrastructure with multicast trees for many reasons. First, one reason they could live with ingress replication, with some of their traffic, or they don't like some properties associated with the multicast trees. Per tree states, and if it's pin trees, then the soft states refresh overheads, and in any source multicast case, the complexity that comes with the shared tree to source tree switch, and also it's yet another protocol to run, especially for data center operators. Nowadays many of them want to just run BGP. So, but still, some operators, to some operators, it's very important for them to use multicast trees for the efficient delivery of multicast traffic, at least before they can deploy EIP. Next slide. So the proposal here is that we use BGP to signal multicast trees. It could be SG, star G, unidirectional, or bidirectional. You can optionally you can use MPLS data plane. That is as a replacement for PIM signaling, and also you could use it as a replacement for MLDP signaling. But still, we're here using the MLDP FAT because it already provides a nice way to identify the trees. Why I want to do this is sort of talk about it in the first slide. It will remove the PIN any source multicast node complexities. So, and also the soft state. We actually in PIN working group there had been work before to address those two problems, but they are done separately. The PIN port over PIN over reliable transport takes care of the soft states refresh, but somehow its deployment has been limited. Source SSM modes does not have those complexities, but it requires good source discovery methods, and we have been talking about this recently in different ways to do it. And here, using BGP is a very good way to do it. So with that, we can consolidate to BGP signaling. And this is very attractive to at least some operators. So we have single protocol, and it is proven scalable for anything, unicast, multicast, labeled or unlabeled. Next slide. The idea is actually very simple. It still follows the existing PIM or MLDP paradigm. It's receiver-initiated joins, except it's not PIM join or MLDP label mapping, it's BGP messages. And we're here using the leaf AD routes in C-multicast CFA that is very similar to the BGP MVP and leaf AD routes. Each node will just determine the upstream hop in the tree, following the existing PIM procedure or MLDP procedure, and then send the leaf AD routes. The leaf AD routes will encode the SG, star G, or MLDP FAT, and we use route target to identify the upstream nodes. A leaf AD route is processed only by the upstream node, and then it stops there. For you to reach the upstream for the next hop in the tree, a new route will be originated with different NRIs. And to separate the forwarding states, if you are just using a signal in the SG or star G unlabeled state, then you do not need any other information unless you have upstream or downstream not directly connected. And if you're setting up label trees, then you use this tunnel impact attribute to carry label information.
Thomas Eckert. So the hop by hop, I understand, but if I'm doing the BGP hop by hop, doesn't that also mean I would have already wanted to first get rid of, let's say, OSPF, ISIS as the IGP and also use BGP in that case? Is that kind of the direction in the network for which this is? Okay.
It does not exclude the IGPs. If the operator wants to use BGP only to set up unicast forwarding state, then they can do that. And if they want to run OSPF or ISS for IGP, but want to run BGP for multi-factor signaling, it can still be done.
But it sounds that if I still have another IGP and I'm using BGP as my tree building protocol, then I have again this kind of RPF sync problem between another IGP and my tree building protocol. So I mean, one of the biggest thing I could gain is by not having that, because one of the same protocol does give me the RPF information and the tree building, right?
Right. The RPF and the tree signaling, those can be separated, and it's a choice of the operator. It's if they can.
Yeah, I'm just saying, just technically, I mean, that would be a visible benefit. While okay, I want to replace PIM because I hate it more than I hate OSPF or so. That's kind of mostly just, I don't know, religious preferences, I'd say, right? So the thing I don't understand then is how would it work if it only goes through the route reflector? How do I get my hop by hop tree building state with that?
Oh, it goes through the route reflector. Let's say, Lenny, there is a route reflector, and you are my upstream. I don't have the direct BGP session with you, but we all peer with Lenny. Then I send the leaf-AD routes to the route reflector, and route reflector will reflect it to you. That's
okay. So maybe you're explaining it, but how would then my join? Okay, so then there would have to be a target for every individual node, then, right?
Yes, route target, yes.
Yeah, Toros, I didn't quite grasp your question. I think BGP would still be protocol independent in the way that PIM is protocol independent. It uses any protocol, any unicast routing protocol to populate the RPF table. It's just now, instead of a PIM join, it's a BGP join. But why should it matter whether it's an OSPF or ISIS or BGP learned route to make the RPF decision?
No, I mean, it really depends on what benefits you're trying to get, right? If it's basically just around the, as I said, right, I dislike PIM more than I dislike the OSPF or ISIS, that's fine, I get the point. I'm not very much persuaded by the point, right? I'd be much more persuaded by the point of saying that, replacing the IGPs with IBGP, right, or others might led me to have a solution where really, I've eliminated other IGPs, I've eliminated PIM, and now basically, sure, it's modular, but I have one protocol responsible for both the RPF and the tree building, right?
Yeah, but I think this proposal is, while that may be a motivation, that's not the goal. This is just to replace PIM with BGP. For the join component of it. The RPF, it leaves the RPF stuff separate.
No, I totally get that. I'm just thinking about what are the different deployment models, right? Which are the deployment models I think would technically be most beneficial as opposed to primarily religiously driven, right? So that was just the understanding I was trying to get.
Right, so deployment model, if the operator wants to or can replace the IGP entirely with BGP, then yes, a single protocol does everything. If he wants to keep OSPF, but he does not, somehow he hates PIM just so bad that he wants to do BGP, then this also works.
Hi, this is Dino. Could this solution work in the following situation? Let's say you have a leaf spine data center design.
Let's say you're not running BGP on the spine. You're running BGP on the leaf nodes, and the leaf nodes are iBGP peering with each other. You can do the joins according to what you specified, but you may not be able to send directly. Could you encapsulate multicast in the BGP virtual next hop?
If I understand you correctly, so that the leaf routers, they are the downstream and upstream to each other, but they are not directly connected. So indeed, we can use the tunnel encapsulation attribute to specify how to send the traffic, tunnel the traffic between them directly.
So it can work with an underlay that's unicast only.
Yes. And so for any source multicast, we can discover the sources first and then set up source specific trees directly. I'll talk about that source active loss more. The next two slides we're going to skip it. That's just details on the routes and then some detailed procedures. Next slide. And next. So this is the source discovery and for ASN mode. Basically, the first hop routers will just send these BGP source active routes when they discover the sources, when they receive traffic. And magically, the last hop routers will receive those, and they will then set up the source trees directly. In theory, you don't need anything special thing in between. Then just the source active routes will just flood the BGP messages. But using BGP allows us to do more optimization with that source discovery. This is actually similar to MSDP, but extended from MSDP and optimized using BGP, built-in BGP mechanisms. For example, MSDP is mostly among the RPs, and here is between the first hop routers and last hop routers. And there is no periodic refreshing, and there is no RPF check for SA propagation because that's taken care of by BGP. And more importantly, with BGP, if you have the route reflecting in your network, and then the source active routes only need to stay on the route reflectors until some last hop routers are interested in a particular group. At that time, you can use BGP mechanisms to pull the source active routes down to last hop routers.
Stig, how does it compare with your ESR flooding mechanism of the thing?
The main difference is that that is periodic, it's soft state, and this is not. So the scales better.
And also the route vector and the soft state.
And the state's not everywhere, as you know.
Yeah.
Is the SA routes encoded where the source address could be a prefix? Could be an S prefix. Can a source route be an S prefix, comma G prefix?
It can be. Yes.
Okay, that's good.
Next slide. The transition is also it can be incremental. For example, if it's SSM, then you can translate to the transition independently at any node. As long between you and your upstream node, you can both do BGP signaling. You can just do BGP signaling on that hop. Everywhere else, you can still be pinned. And in the ASM case, you can first upgrade your RPs to support the BGP signaling, and that RP will advertise source active routes based on the registering state. And then after that, any hop, any router can upgrade independently. Let's say you have a transit router is upgraded first, and that transit router receives a StarG PIM join from downstream. Then it can terminate the PIM join, StarG join right there. doesn't do anything until it receives a source active routes somewhere, and then you will just join the source specific trees from that router.
This is Dina. I think that could be an implementation option because you might have some join latency if you do that, because there might be a lot of SAs, right? Or are you just sending the SA routes down to the Gs that it join? So, I mean, I think it could be just the state bandwidth trade-off issue, and the implementation could decide.
Yes.
So what's been the experience on all these, various, especially in MDP and also in the last few years, ASM stuff? Because, one of the main pain points we had with MSTP was carrying the first packets to avoid the first packet loss. And I think all the, newer solutions we built around, also BGP, MVPN signaling and so for ASM, none of that, I think, cares about the first packets getting lost, right? So any data point on that we're all happy with that, and that 10 years ago in MSTP, we just, paint ourselves way too much?
BGP MVPN actually has a mode where it mimics the PIM ASM mode, where you do not have you do not lose the first packet. So, if your implementation is make sure of that. And there, indeed, there is another mode where it relies on the SA routes for the downstream P to discover sources. So this is similar. And indeed, some customers do care about not losing first packet. They care about that dearly, and we find that through some painful experiences after the
Is this solution?
The solution does not address that problem, but if you really care about that, PIM bidirectional trees that can be set up using this as well. That does avoid the first packet loss issue.
Jay Collin, it sounds like there's a claim here that there are, in practice, current networks where adopting this is a smaller barrier to adoption than switching to SSM, say, and running PIM. Am I understanding that correctly?
Can you say that again?
It sounds like there's a claim that in practice today there are networks which currently cannot deploy multicast because using only SSM, for example, is a barrier to adoption. But this would not be a barrier to adoption. Is that accurate? That you've encountered such networks?
We're not saying that. We're just saying that the tree setup can be done by BGP, and the source discovery can also be done BGP.
Okay. But you have reason to believe that this would be a superior option for adoption for some networks to using existing mechanisms. In particular, SSM only deployments, say.
Yeah, this is indeed a better option. Even if you're just using SSM, because when it comes to PIM signaling, well, if you do care about the source state refreshing overhead, that kind of thing, right? So if you are happy with your current PIM deployment, then there is no point talking about it. See, there are operators who care about that. I just don't like PIM, right? For whatever reason, right? So this would be an option, especially if they want to deploy BGP anyway.
You could always run PIM over TCP, right? There's a draft for that. That saves the peer app.
Just if I understood Jake's question correctly, was it about why we're still wanting to support ASM in a solution like this, or and that doing SSM support alone wouldn't be sufficient? Was that the question? Right. I think there are little, intelligent way to understand this other than, they put a job description up and just put BGP in there, and if they put PIM in there, they just get, 5% as many people that want to be operators for that, something like that. I don't know.
Yeah, I think we're all trying to climb in the heads of why people would do this or not, and some of the speculation is a single unified protocol that obliterates all others. Because that's somehow simpler. I've never been convinced that one protocol is better than two protocols when you're doing the same thing. Just doing the same thing in a different protocol isn't removing a protocol; it's renaming it. So I find that reason unconvincing, but people love to use it, and so, why stop them? Another motivation, if we're climbing in the heads of people, is, we've been using BGP as a multicast routing protocol for MBPN. We've been doing it for GTM, and there's, it's being used in between CE and PE protocols. There's been positive reaction. The experiences have been, a lot of providers have found BGP to be a good protocol for this. This is kind of the last frontier. If you've gone this far with BGP acting as a multicast routing protocol, why not go the full way and completely cover everything? And as we've seen, it kind of has some nice features that solve some of the, that handle some of the things that PIM and MSDP didn't handle so well. So, I think it's a cool idea. Just it's the obvious next step for if going from MBPN to BGP MBPN to GTM. They seem to be going well. Why not stick it in there? And some people might like it, some people might not. But it's another option to do this, and it might actually be better than PIM in a lot of regards.
This is Dino. So I was thinking, could somebody implement this with 2 BGP instances? And the reason is there's a lot of stuff in BGP, and putting everything in one basket creates a larger fault non-isolation domain, right? So could somebody run BGP as they are today, and say they're running PIM alongside? They want to replace PIM because they want to go on a path toward unifying this all under one process. Could they replace the PIM with a different instance of BGP, where the join routes and the SA routes just run into one instance, and then BGP as they have it today runs in a separate process, and then at least they have some fault isolation? Because I think this protocol, or this instance of the protocol, will be more chatty than typical BGP, because the joins and leaves happen much more frequently than route changes usually, right? Because it's a membership, it's an application level driven action. So would you comment?
Definitely you can, this is just specifying the protocol. The implementation can be, you can have separate BGP instance just for this purpose. And about chattiness, then you can also do route dampening with BGP.
So what I'm getting at is, would you as a vendor recommend this as a transition mechanism to a customer to take these small little steps rather than taking big steps?
I think that's really up to the operator, because some operators may feel that it's important for me to separate these two, and some may just prefer to have a single one instead of running two. It's totally up to the operator.
So where can you do the demultiplexing these days? The unicast BGP and the multicast BGP here, they would still run on the same transport port, right?
Say that again?
They would be on the same BGP transport connection. So you would have to demultiplex after that, right? So there is no natural demultiplex. I'm asking, right? So I'm trying to understand.
I think that's flexible. It's you can use the same session or you can use different session. It does not matter.
Okay, so if you're basically setting up your multi-session BGP, that basically would be a way to make it then also independent instances.
If you want to, yeah.
And so, what's the story about SGRP bit prune state, or do you have what's the trick to keep the shared and the shortest path tree aligned, or what's the story here?
Because we don't do the a share tree anymore, so there is no RT.
Okay.
Joel Yigley. There's a whole lot of TCP ports other than 179 that can have listeners on them. So one way to demultiplex them is to never plex them. Yeah.
Ashutosh from Cisco. So what I understood is that basically you are getting rid of all PIM messages going across, but PIM still would be needed on the box, the router, to the last hop, DR, these kind of functionalities, asserts.
On the source network and on the last hop or receiver network, even there you don't need the PIM anymore, because there is a separate draft that ICE championed. It's the DR election. That is not tied to PIM protocol itself. So.
Okay. What about asserts?
What?
Asserts?
Assert. There is a section in the draft talking about that. Assert will be a control-driven assert using a BGP route. We call it SPMZ route. That replaces the data plane and data plane trigger assert. Yes.
Okay. That would mean more latency in getting rid of duplicates. Is that correct?
Yes.
Sure. Isn't this problem really the fact that you're trying to get the joiners and the receivers together in one spot and share the database across the entirety of the network? And do we have to use BGP for that?
So there are two aspects here. One is the actual signaling of the tree that it joins. That's one thing. Another thing is the source discovery. And I think you're talking about the source discovery itself, right?
Effectively, I mean, part of the reason PIM's so complex is because you have to figure out a way to get the sources to the people who are interested. And if you change a protocol to disseminate that information across the entirety of your network, a lot of the problems of PIM just go away. And that's what you're doing here, correct?
Right, but the way you disseminate that source information is not practically it's not through flooding, because you typically in your BGP network you will have route reflectors, so the source information is only kept on a route vector.
I'm not saying BGP. Do we have to use BGP? Is the fundamental why choose BGP when the goal is just
so yeah. I mean, if you look at it, as Dino said, I mean, we have hard state with port. We would have, with the flooding from stick a similar approach with respect to only using S, G state, right? I think there seems to be the one trick here which we haven't gotten an equivalent from, which is the kind of star, G join to kind of this route reflector thing. But yeah, we could do the same thing without BGP, and I think for the majority of operators, we wouldn't have achieved their original goal, right? Which is that consolidation into one protocol.
So what I would suggest, so you could hit a home run out of the park, is you said there's no shared trees, so don't carry star, G. Don't have SA routes, only support SSM, and you're going to have it lean and mean.
or maybe just split it up in two drafts, right? So then there's the good draft and there's the bad draft, and you know which one you need to implement first.
Next slide. So, comments and feedback, we had a lot today. Please continue to share your comments and feedback. And we will add more details like handling the neighbors not therapeutic metric. The concept is there, it's just we need to put in the details. So in this discussion, today's presentation, we focus on PIM, and this draft also covers replacing MLDP. And that's probably something that some customers are more interested in doing in the first step. And we are getting some good interest from some customers here. So and the feedback from this IETF so far has also been encouraging. So I feel good. Thank you.
Yeah, I have a question for you. So, are you trying to get this adopted in the best, and has it been discussed there, or?
I think the concepts of the tree setup, whether it's PIM-based or NLDP-based, that's well understood before and then implemented by vendors. And here we're just talking about BGP signaling. And the routes, BPD routes, SPNG routes, all those things are BGP specific. I feel like the best is probably a better place. But we will include the PIM in the loop. And in fact, in today's presentation, we got more feedback and comments than I got from the best working group. So this will definitely include PIM group in the loop.
I agree. To me, it seems like, the technology is sort of best, but it's great that you present this here, and I'm sure we're happy to provide more input. So, yeah. Yeah, I guess we're done then. Anyone have any additional things they want to say, or questions or comments or anything, announcements? Okay, guess we're done for today. Thanks everyone.
When do you want to do an algorithm test? I'll probably have my version of PIM doing so I already have 549 in my version, but I don't have quite the subtle that we have. So my use case was only data center, right? So when I'm connected to someone, I only have one neighbor on that interface, so all I have to do is find a neighbor.
Yeah.
Right. So, but it's really easy to add the ability to send a V6 address.
Yeah.
All my secondary addresses, and it's really easy to find a neighbor by my secondary address.
Yeah.
So I'll probably have it done today.
Okay, cool.
So,
yeah, that's great. I was almost surprised when you had all these comments because most people I think was strange, but
we think about 55, 49,
yeah.
sometimes
So that's great. Yeah. Yeah, it's so many issues, but I was thinking about this, if you just do the address list, it's almost like a draft to be informational, just saying this is something you can do. But because it's actually, then if you're saying that this might be a good idea, you might want to make it, I don't know, experimental or something. And just, it's changing slightly how that option is used.